Okay, I have another really powerful result to share with you regarding the Gilbreath principle when it is applied to an alternating red-black deck or packet. Okay, so that's what I have here. The cards are alternating red-black throughout, or black-red throughout. Okay, now the Gilbreath principle says that if we reverse count, so you reverse count any number of the cards here, okay, and where we have a cyclic arrangement of the cards, the cyclic arrangement here is that they alternate in color, red, black, okay. And then if you perform anything that's equivalent to a riffle shuffle, and so it could be a rosette shuffle, you could even do a ferrule shuffle if you like. So if you just do a riffle shuffle, and it doesn't have to be at all perfect, just standard riffle shuffle. You could have the spectator do that actually. This deck's going to have some really interesting properties, and this is something I mentioned recently in a video that I posted. So let me just quickly review that. The Gilbreath principle says that each pair of cards taken from the top will consist of a red and black in some order. Now we won't know the order, and most likely the order will switch, but each set of 2 cards will consist of a red and a black. Okay. Now, what I have discovered beyond that, so that's the Gilbreath principle conclusion, but I have found something even more powerful in a sense, because it's going to enable us to separate this Gilbreath shuffle deck into a pile of red cards and a pile of black cards by just asking a couple of simple questions for each set of 4 cards. Okay, and so I have a theorem here that I'll quickly explain. Every post-Gilbreath shuffled alternating red-black packet, so that's what this is. I've riffle shuffled it now after reverse counting some of the cards. This here will be, quote, the concatenation of 2 cycles with cycle length 2. So they would have to look like one of these over here, red-black, or black-red. Or it could be that sets of 4 look like this right here, which is a quasi-Bessey sequence of order 4. Now, in simpler vocabulary, we would call these mirrored packets here. So it's red, black, red. So it's like mirrored. It's kind of the mirrored reflection of itself. And here it's black, red, black. Okay, so these are cyclic and these are mirrored constructions. Now, it ends up that these are the only 4 groups of 4 that you'll get taken from the top of a Gilbreath shuffled alternating packet. So let me just kind of quickly show you that for some of these. Okay, so here are the top 4 cards. So which one does it fit? It's a mirrored construction. It's red, black, red. Okay, what about the next 4? That's alternating black, red. So right here, okay. Maybe we'll just do a couple more. This is alternating, but now it's red. Oh, no, sorry, this is mirrored. So this is red, black, red, okay. Now it's possible to get any one of these. Now this one is alternating, black, red, right here, black, red. Okay, and so if you want to check this for yourself, this is actually a theorem that's provable. Here, this is a little 2 cycle. It's a cyclic construction. Black, red throughout. Here's the mirrored packet. Black, red, black. Okay, one more, and then you'll just you can check this on your own. Here's an alternating one. Red, black. Okay. So that's there are only 4 groups of 4 cards that you can get from a Gilbreath shuffled alternating deck like this. Okay, it's going to have to be one of these. And as you saw, I think in the particular ones that I showed you, I think we had at least one of these in some order. Okay, and the concatenation just means that they're put together. So as groups of 4, each set of 4 will satisfy one of these conditions here. But we won't know which one and how those are ordered. That's the important thing. Now, despite that, we're going to separate these cards into a pile of red cards and black cards by asking a couple of strategic questions. Now, I do need to point out that in information theory, Claude Shannon revealed to the world that if you have a string of 4 dichotomous outcomes, like heads, tails, or something, here it's red, black, are the 2 outcomes that you can get. And if you have 4 of them, there will be 16 different permutations of reds and blacks. So they could all be red, they could all be black, they could alternate like here and so forth. So the idea is that for the first position, it can be a red or a black generally, right? So we're just talking about what kinds of things you can get in general if you mix the cards. The next one could be red or black, 2 possibilities. Next one could be red or black, 2 possibilities, and the last one is 2 possibilities. So the fundamental counting principle says the total number of ways that these colors could work out in the way of red or black cards is 16. It'd be 2 times 2 times 2 times 2, 16 possibilities. Now, Claude Shannon showed that the minimum number of questions that would need to be asked to identify an exact outcome would be log base 2 of 16. Well, log base 2 of 16 is 4. So essentially, you need to ask a question for each and every one of these cards. So 4 cards. Well, we're not going to ask 4 questions for each set of 4. We're going to ask only 2 questions. And those 2 questions will enable us to separate this perfectly into a red pile and a black pile of cards. Okay, so this is what you do. Have the spectator tell you, or you can look at it as well. It's not a problem. Look at the color. So here, this is red. So what I'm going to do is I'm going to set down each set of 4 where the top card's red. So red. So 1, 2, 3, 4. What's the next card's black? And then set down the black ones over here. So we're working with sets of 4 cards, and then we're looking at the top card of each. Well, that's red, so I'll put it over here as well. This is black. Black again. So go over there. Black again. Very good. Red. Red. Red again. Black. Red. And red again. So we're just dealing out 4 cards at a time. 1, 2, 3, 4. Okay, so just remember, this is the set of cards where at the bottom of each block of 4 cards, the card is red, right? Okay, so we have red bottom cards here, and we have black bottom cards over here, okay? So maybe what I'll do is I'll put that up there for now. Now, think about it. So for the left pile where the bottom cards for each set of 4 is red, where does that take us? What are the possibilities? Well, if you look at these, there's only 2 of the 4 outcomes that have a red card at the bottom. It's these 2 right here. So each set of 4 could be an alternating packet of black, red, or it could be this mirrored packet of red, black, red. Okay? Now, to ascertain which it is, you just ask a second question. Okay, so we won't need to ask 4 questions for each of these, just 2. And here is the second question. What you do is now you go through the same packet and you just look at the top card or ask the spectator what the color of the top card is. It's red. Well, you can see what's going to happen. It puts us right here. Okay, so what that would mean then is that this one's red. I'll go up here. 1, red, black, red. Okay, so we're going to set all the red cards here and the black ones here, and I can even show you that we'll succeed. I wonder if we should do it face up just so you can see that. Maybe that would be a good idea. Okay, the next one's red. Okay, so we know that because the bottom card of that set of 4 is red, this must be a mirrored case as well. Red again. Okay, what about this one? Oh, golly. Okay, black. So remember, this is the top card for a set of 4 cards. So this is black, and this is black, and this one down here is red. That's why it was in that pile. Okay, so black and then red at the bottom puts us right here. This is cyclic. So it must be that it's black, red, okay? So the top card was black, so it must go there. The next one goes there. Next one must be black, and then the next one must be red. Okay, let's take a look at this one. Same thing. We're looking at this case right here. Black, red, black, red. Now we're back to this one here. So this must be red, black, black, red. Okay, and then what about here? Same thing. Red, black, black, red. Okay, so we've separated some of them, about half of them, into red and black cards. Now what was special about this other half? This is the half where the bottom card of each set of 4 is black. Okay, so you just kind of change the focus. So it's either this one here or this one here. It's just one of those two. This one's cyclic, this one's mirrored. Okay, so as you just look at these or have the spectator tell you what it is, since the bottom card of this set of 4 is black, that's why it's on the right, and then we just saw that the top is red, it has to be a cyclic packet here. Okay, and then since the top one is red, you go red, black, black. Okay, what's this one? Oh, this one's black. Well, we know that the bottom card here is black as well, so this must be a mirrored construction, namely this one, so it's going to be black, red, black. Okay, and then here this is red again, so it must be red, black, black. And then this one's red, black, black. And then this one, same thing there. Okay. Now I don't recommend that you deal these face up to the spectator. Okay. I'm doing it because this is meant to be an educational video for you and give you some ideas as to how you can use your knowledge of the structure of this Gilbreath shuffled alternating deck of red and black cards. Okay, so that would be one way to take advantage of the fact that you know that each set of 4 must look like one of these. And so essentially what we asked in the end, what we found out was we found out the color of the top card and the bottom card. Top card and the bottom card and so forth. Well, with that information, you know which one it will have to be. Okay, since there are only 4 possibilities as mentioned at the beginning. Okay, so the Gilbreath shuffle, it does limit the kinds of structures that you get out at the end. Okay, even though when you look at a Gilbreath shuffled packet, it sure looks pretty random and chaotic, but there's still quite a bit of hidden structure there that you can take advantage of. So anyway, I thought I would share this with you. I think it's a really cool result. And it enables you to essentially pull apart a riffle shuffled alternating deck when you don't even know how the cards were interlaced. That's the crazy thing, is those cards could have been interlaced in any of many different ways, but yet we can successfully set aside the red cards on the left and the black cards on the right, and we don't need to ask 4 questions for each set of 4. We got away with asking just 2 questions. And that's for the simple reason that the kinds of structures that are possible from a Gilbreath shuffled alternating deck like this is limited to one or any of these 4 possibilities. So anyway, I thought I'd share this with you. It's kind of a fun result, and I think there are other ways actually to take advantage or even come up with a way to separate the reds from the blacks once you know that each set of 4 has to fit into one of these categories here. So I've just shown you one of probably many ways that you could use your knowledge of the ending structure and pull that deck apart into 26 red cards and 26 black cards. Thank you for watching, and take a look at other videos on the Absolute Math Magic channel.